Hey everyone. So for the tute prep for week 3 tutes this week, you all had a go at coding infant behavior. Now, unbeknownst to you, I told half of you that the babies you were coding that baby A was preterm and baby B was full term, and the other half of you, I told you the other way around, that baby A was full term and baby B was preterm. And so, what we want to see in this data today is whether that knowledge of babies' preterm or full term status influenced how you rated their competencies on these locomotor tasks. So, in reality, both of those babies were full term, they were born within 24 hours of each other, and there should be no systematic difference between the ratings that Group 1, who thought that baby A was preterm, and Group 2, who thought that baby A was full term, right? So, because lots of you are taking RM2 right now, I thought it might be useful to demo how we might analyze this data in Jamovi, which is the platform that you use for statistics labs. So, for those of you who aren't taking RM2, Jamovi is a really useful open source piece of software that's a lot like SPSS, but free. So, if you ever need to do some plotting of data or analysis, check it out. For those of you who are doing RM2, I'm hoping that some of you in class have actually got the software downloaded on your computer. If you do, let your tutor know, and you can be the driver for your group. All right, so I'm going to show you how to get some descriptive statistics and some plots from the data that you all produced. And then you're going to get into groups and have a go at doing it with the other skills that I don't demo. All right, here we go. So I'm going to find Jamovi on my computer and open it. What I want you to do when you start with your groups is go to Moodle and find this file. I have put it on my desktop. I suggest you put it on your desktop too, called locomotor.org. You can find it in the week 3 Moodle section under tutorials. Download this CSV file onto your desktop, and then you can find it using these 3 pancake things. So if you open the file, I have it sitting on my desktop. I'm going to open this file and it will pull it up much like an Excel sheet would. Make this big so that we can see. So you can see that we've got a few variables here. This is participant ID. So each row of data comes from a different student, participant, or rater. We have information about which group each participant was assigned to. So group 1 thought that baby A was preterm and baby B was full term, and group 2 the other way around. And then each of these variables have individual participants' ratings that are averaged across the different tasks. So for you are asked to rate a few different tasks, and I've averaged scores into a single mean for fine motor skills versus gross motor skills versus play versus self-help skills. So we have a mean for each participant, for each baby, we have a mean for each skill. So what we want to know is, are there systematic differences in how group 1 and group 2 rated baby A's fine motor skills, for example? So let's get some descriptive statistics. So we want to get a mean rating for each group for each baby and skill, right? So let's start with fine motor skills. So you can, over here, there's a little bar plot icon that we can use to get to explore the data, to get some descriptives and some plots. So if you click on that and click descriptives, it will pull up another window. You can make this a bit bigger so that we can see. And here, the default descriptives that it will give you are the number of observations, whether you have any missing data, the mean, median, standard deviation, and what the maximum and minimum scores are. We can change that. We're really only interested in, let's say we want the number of observations, but we don't care about missing data. We want the mean, but we don't care about the median. And we want the standard deviation, but we don't care about minimums and maximums. So let's just make a simple table. So we can minimize that again. And then what we're really interested in is, let's start with fine motor behavior. So I want to know the mean ratings for baby A and baby B fine motor behavior. So I'll put those two in as variables. But so here it's given me on average across both groups of raters, it seems that you all thought that baby A had better fine motor behavior than baby B. We've got a mean of 3.29 for baby A's fine motor behavior and a mean of 2.25 for baby B's. Now that's interesting, but what we're actually interested in is whether that differs by group. So it doesn't make a difference whether you were told that baby A was preterm or full term, as to how you rated their fine motor competency. So we're going to add another variable here. We can take our group variable and add it to the split by box. And now it splits that mean by group. So you can see we are really interested in comparing within babies across groups. So does group 1 and group 2 rate baby A differently? Does group 1 and group 2 rate baby B differently? Because the baby's behavior is the same, it's just that group 1 and group 2 differ in what they thought the status of that baby was. So you can see here that the mean fine motor skills for baby A looks like group 2 rated it higher, a mean of 3.42, versus group 1, a mean of 3.16. And the opposite is true for baby B. So for baby B's fine motor skills, group 1 rated it higher with a mean of 2.27. Versus group 2, a mean of 2.24. Now this difference between 1 and group 2 is smaller for baby B than it is for baby A, but this looks like it's in the right direction for our hypothesis, right? So we predict that groups will rate babies as less competent if they think the baby is preterm, right? So we know that group 1 thought that baby A was preterm and group 2 thought that baby A was full term. So the directions of those means go in the direction that our hypothesis is. Same other way around. So for baby B, group 1 thought that baby B was full term and group 2 thought that baby B was preterm. Okay, so we can plot those mean differences within the same window. So if you pull down this plots, in this case we're wanting to plot means or averages, so it probably makes most sense to use bar plots. If you just click the bar plot, it will plot separately for baby A's behavior and baby B's behavior, the difference between group 1 and group 2. And so if we pull this up, we can see that magnitude of difference that we see for difference for baby A and B is reflected in the plots. So the ratings are of baby A are higher for group 2 than they are for group 1. There is a much smaller difference between group 1 and group 2's ratings of baby B. All right, so what I want you to do is get into groups. One group can try getting plots that look like mine for fine motor skills, and 3 other groups can try and get plots for descriptors and plots for gross motor skills, play skills, and self skills, and then report back to the class as to whether the same pattern is true for those other 3 skills. So here it looks like we are showing the pattern that we see in the plots is consistent with our hypothesis that you will rate babies as less competent if you think they're preterm, but see whether that plays out for gross motor, play skills, and self-help skills. Good luck.